Hello. Now we're going to roll a die again, and we're going to roll a die until a 1 or a 5 appears. So the first thing we got to think about is what's the probability that you get a 1 or a 5? And that, there's two values out of 6, so 2 out of 6 is 1/3. So there's a 1/3 probability that you get that. So on the first one, that's going to be 0.3 repeating. And the second one, we're going to do, you got 2/3, because you missed it on your first one, times 1/3. And then you can multiply that out and get here. And this one, 2/3 to the second, multiply it by 1/3, and get your value here, and so on and so on. But our calculator, if you want to see it, gives you a short way with a geometric PDF. So this one just gives you your probability of success. Here we can type in 1/3. And our x value, let's do 3. So if we want to find that geometric probability, that's 0.148. Now if I wanted to change it, I could just do this and change that to say 5. And you can see that the probability that I takes 5 times is 0.065. 8, I think it said, something like that. And you could do the same thing and fill in the whole thing. Now if you want to find the mean and variance of a geometric random variable, you just take 1 over p, and the variance is 1 minus p over p squared, and just square root it if you want to find the standard deviation. So if you want to find the mean and standard deviation for rolling 2 dice, so the mean is 1 over 1/3. If you know your fractions really well, you can see that that's just 3. Or you can just take 1 over 1/3 on your calculator and see that it's 3. So we would expect about 3 rolls before we get it. Sometimes a little less, sometimes a little more. Now, our variance was 1 minus p over p squared. So you just take 1 minus 1/3 over 1/3 squared, and you get your answer. So you could do it without your calculator. The math teacher in me wants to do it. So that's 2/3 over 1/9. When you're dividing fractions, that's divided by 1/9, which is multiplied by 9 first. So that's 18/3, which is 6. So your standard deviation, standard deviation is just going to be the square root of 6, whatever that is. And again, you could do this on your calculator without doing the fractions if you'd like. So another one says, what's the probability it will take more than 5 times to get doubles? So we're using the same situation. If I more than 5 times, it should be low, 7 and so on, but it's going to be from here all the way to infinity to find the probability. Now, just like we use PDF to find each value here, we could use a CDF to get from 5 down and subtract from 1 to get on the top end. So if I do the distribution, geometric CDF is on the bottom. The probability of success is 1/3 again. Now we want our x value to be up to 5. So when I plug that in, that tells us that 0.868 is below 5. So now I just have to take 1 minus that value to get about 13% is of the time it's going to take more than 5 rolls to get doubles. All right, I think we're done. All right, good luck with your on your owns.